So, okay, so Elon Musk, okay, he wants to, he's a humanist, right?
Yeah.
Colonizing on Mars. He's a very smart guy, okay? This is not a guy that's just, have 3 shots of tequila and says, hey, guys, I'm going to go colonize, and I'm going to have life on Mars, right? Mm-hmm. For somebody as smart as him to say something like that, what are his hurdles of that becoming a reality?
Mars is a very hostile environment to live on. I mean, it's much harder to live on Mars than it is on Antarctica, put it like that, right? Antarctica has an atmosphere that we can breathe. That's the most obvious basic thing. Its temperature is actually similar to Mars. It's not that different from Mars, the temperature in Antarctica to Mars. So the temperature is very similar, but Antarctica is covered in ice, so you've got plenty of water. So you have access to water, you have breathable air. All you really have to do is wear a coat and some protective gear, and you can survive in that environment. You're not going to survive in Mars under those same conditions. Mars is a place that has no surface liquid water, as far as we can tell. There's ice on the polar caps, but how much we don't truly know. It doesn't have, even the atmospheric pressure is so low that it would kill you, let alone the lack of a breathable atmosphere. And on top of that, it lacks any, there's no boat that can come and save you. Like if you need, infrastructure to be delivered or water or supplies to be delivered quickly, it's just totally inaccessible. It's going to take 18 months or something to get the next care package delivered. So it's going to require, it's going to be the greatest survival challenge for humanity.
When you hear him say that, what do you think?
I think it's it's some of my colleagues kind of think it's ridiculous and think it's just totally crazy that we'll ever do this. I've always felt like it was, if someone wanted to spend their own money to try and do it, like all power to them, let them try and do it. I get the philosophy. The philosophy is, as long as we're all on planet Earth, we're at risk. Because all it takes is one giant meteor or one nuclear war or whatever cataclysm you want, and we're all gone. And so if your objective is to preserve the species, then it totally makes sense that you would want to have a second base. And whether that base be on the moon or Mars, I don't really have a strong opinion, but I think there are definitely advantages on Mars because it's a higher surface gravity. It does appear to have a bit more water. The temperatures, there is some atmosphere at least, whereas the moon has no atmosphere at all. So I think but it's further away. So that's another challenge to how do you actually get there in the first place? How do you actually service it and have infrastructure go back and forth? But I think it's a cool goal. I don't want to live on Mars. I mean, like I said, would you want to live in Antarctica? Like if someone said, do you want to live in Florida or do you want to live in Antarctica? I don't want to live in Antarctica. And I certainly don't want to live in a place that's even worse than Antarctica, which is Mars. So I have no desire personally to live on Mars. It'd be cool to visit for a week, but it's so far away you can't really do that. So I don't know, all power, if someone wants to try that, go for it. And, people are lining up coast to coast to be the first astronauts to Mars. I think if you put out a call for astronauts for Mars, there'd be no shortage of volunteers who'd be willing to end their life on Mars if that's what it took to go there. And you need people like that to push the envelope. I just don't want to do it myself. And that's where it's like you have to divorce maybe how you feel about something versus someone else putting their life at risk.
Do you have any desire to go into space or no?
I'd love to go to space. Yeah, I'd love to do a cruise in orbit, see the Earth from space. It's been a dream of mine since a kid, but only as a paying probably tourist, I expect that to happen, and I would be okay with that if it became something where you could spend $10,000-$20,000, go up, do a few orbits.
Nothing to be out there for a year and explore and, as a big project, that's not something
No, I mean, you've seen these Starliner astronauts there, which are stuck there at the moment.
Yeah, the Boeing one. I saw that, the lady and the guy.
Yeah, so
probably
Suni Williams.
25 January, they'll be able to come back.
I know, they're probably stuck there till February, it looks like, at this point, which is...
Stranded in space. NASA doesn't see the Starliner astronauts that way. NASA doesn't say
they don't like that word. Yeah, but I think they are kind of stuck there for the moment, unfortunately.
Yeah, but they seem pretty chill about it. They don't seem like.
Well, they're trained for that. They're trained.
So let me ask you this question. So do you think man landed on the moon?
Yeah, 100%.
You're saying 100%. Tell me why you say 100%.
Because we can see from you look at imaging of the surface of the moon. So you have like these orbiters which are currently going around the moon. Again, you can download the data. Anyone can download the data. This NASA public data policy that we have. And you can download that data and you can see the tracks of the rovers, of the astronauts as they drove around. And you can line them up to the video footage of them driving around the surface. You can see the landers. You can see, the infrastructure that was left there. There's even mirrors that were put on the surface of the moon. It's called the laser ranging experiment. And they left these mirrors there, and we actually bounced lasers off the surface of the moon, off these mirrors. And using that, we can measure how far away the moon is. Every day we can do that. So we can measure how far away is the moon today. And we've been doing that for the last few decades. And as a result, we know that the moon is receding away from us at about 1 inch per year, about 4 centimeters per year. And this is due to the tides that the moon raises on the Earth and dissipates energy through the tidal action on the planet. So this is actually, one of the most amazing experiments, I think. It's actually now getting quite dusty. They can also tell from the lasers the response time is not only getting longer, but the amount of light returning is diminishing. So they can tell that dust is slowly accumulating on these mirrors and even infer from that the micrometeorite rate that's happening on the moon. So when you look at all the amazing stuff we can do, there's obviously moon rocks that we have. We know about the origin of the moon from the moon rocks. We took those moon rocks that the Apollo astronauts brought back. We measured the isotopic ratio of oxygen 18 to oxygen 16 from those rocks. And by looking at that oxygen isotope ratio, we were able to tell that it was identical to that of the Earth. And that was obviously there's many of the differences in the rocks, but that particular ratio was identical. And that told us that the moon used to be a part of the Earth, which is pretty wild. So actually the origin of the moon was that it was at one point in its history part of the Earth.
What happened?
Right? So this is called the giant impact hypothesis. So it's thought that when the Earth first formed, it was actually larger than it is today. Would have been maybe we call it a super Earth. And it was this big ball of molten lava. And there was this episode in the history of the solar system called the late heavy bombardment that we believe happened. We can see that because we see Mercury's been covered in meteors. We can see lots of evidence from simulations of looking at how Jupiter moves through the solar system. So we have lots of evidence that there was this late heavy bombardment. And basically, there was just a lot of crap around, just a lot of stuff moving around the solar system. And this Mars-sized planet that we call Theia, a Mars-sized planet, drifted too close to the Earth, or the super Earth, smashed into it. And that Mars-sized planet basically totally vaporized. It was destroyed in totality, but it knocked off a huge chunk of the Earth. And that huge chunk is what formed the moon. And that's why the moon has the same isotopic ratio in its rocks that the Earth has.
That is this I'm looking at it right now, giant impact hypothesis. Rob, just pull up the
theory,
the Wikipedia to it and show the picture. Is that kind of what you're saying to the right?
Yeah, I think most of the time you see a simulation, it's actually more of a grazing impact than a head-on like that. Just because people experiment with the geometry and see how the outcomes are in these supercomputer simulations. But yeah, that's essentially what you're looking at. This kind of incredible collision, which have happened 4.5 billion years ago.
Wow, I'm looking at these simulations right now. There's a bunch of them online.
It's possible that actually life had already been on the Earth at this point, and it was basically totally wiped out from that impact.
What?
And then life had to get going again after the impact. So that's a really interesting question. Did life form before the impact and get totally wiped out?
What do you think?
I have no idea. I mean, if it'd be a huge discovery if it was true. And we have no way of actually essentially observing that. But if it was true, it means that life started twice. If life started twice, it means life is everywhere. But yeah, look at this thing. It's smashed together, and then you can see this debris start to coalesce. Sometimes in these simulations, they actually form multiple moons or 2 moons. And what often happens in these simulations is, you can see we're just getting 1 moon here in this case. The moon here would have been much, much closer to the Earth. You see this?
Yeah.
It's super close. And that's why, I told you the moon is moving away at 1 inch per year, right? So if you rewind that clock back,
4
that 1 inch per year,
yeah,
and you account for the acceleration due to tidal effects, it actually ends up being right there where we see it in the simulations. at the right point. This is called the Roche limit. It's basically the closest distance gravitationally where you could form an object. So the moon formed at this close-in distance where it can coalesce, and it's been gradually receding away from the Earth ever since.
David, what's the likelihood of something like this happening again?
This is one of the reasons why we want to look for exomoons. This impact could be the reason why we're all here, right? So had this collision not happened, the Earth has plate tectonics, right? And those plates rub against each other. It turns out that's probably quite critical for the emergence of life on this planet. You have this interaction of these carbon cycles and nitrogen cycles where material can be recycled as it subdues and it kind of lands on the bottom of the seabed. It eventually subducts under different plates. This is the Earth's recycling mechanism. If we didn't have this, when something died, like a whale, and it just landed on the bottom of the ocean bed, its carbon could potentially be stuck there forever and just locked up forever. And eventually there'd just be no carbon left for things to make plants and trees and animals out of. But the fact is that that reserve of carbon gets subducted back into the magma and then gets re-released through volcanism. So this is one of the ways in which the Earth recycles material. Now, had this impact not happened, it is possible that we would not have plate tectonics. The reason being that rather than having a series of very thin lids like this, which can rub against each other, it would instead just form one very, very thick, giant lid all the way around, which couldn't move. And we think that's what's happened to Venus. If you look at Venus, it just has one giant thick lid. We call it a stagnant lid. It has no plate tectonics. That's why probably it's not a very hospitable place for other reasons as well. And so if Earth had formed a stagnant lid in the same way Venus did, which probably would have happened without that giant impact, I think, then none of us would probably be here in terms of complex life on this planet. So it seems like there's a lot to thank for that giant impact.
A lot to thank for that giant impact. But it's also very likely that there could have been civilization right behind it. Would anybody have survived that impact?
I don't think there would have been a civilization then, because Earth formed, let's say, like 4.6 billion years ago. This happened at 4.5. So you've got 100 million years at most for life to get going. And it took on...
It's plenty.
Is it? I mean, it took 4 billion years to get from single-celled organism to us the second time around. Maybe there was a first time around, but the second time around, we know for sure it took 4 billion years. So can it do it in 100 million years? That seems very tight, right? You're asking for a factor of 40 quicker for evolution to play out.
It's amazing. Like when you actually think about it, your life is like a split second.
Right.
It is like in the bigger scope of things, we are just regular.
I know.
Like this. Listen, You think you're important. Relax, buddy. You're out of here. Next.
Right.
It's so wild when you look at it
in time and space.
Yeah, it's so interesting when you look at it from. It's actually humbling, for you to have some perspective when you really start thinking very highly of yourself. And say, I got this degree, I made this much money, I'm this, I'm doing that. Yeah, you're not that big of a deal, bro. Just relax.
Well, have you ever heard of Carl Sagan's Pale Blue Dot speech? You never seen this? Maybe check it out afterwards. You should listen to it, guys, online. It's a wonderful speech that Carl Sagan gives, and it's a photo of the Earth taken from about the distance of Neptune and the outer edge of the solar system. And this is a photo of the Earth, and the Earth, in this image, is in that sunbeam. There it is, that little tiny speck of light. That's the Earth. And he says, he's beautifully eloquent, and he says, every person who's ever lived on, every general, every religious leader, every lover, every child, every grandparent, everyone you've ever known, everyone you've ever hated, everyone you've ever loved, everyone lived on that tiny speck of light suspended in a sunbeam. And that's what we're all fighting over, right? In these wars, we're fighting over a fraction of a dot. That's what we're fighting over. And just the madness of it, when you look at it from a cosmic perspective, is baffling. And that's why I love astronomy. It is said to be the ultimate humbling experience.
How about, I know, again, you're not a geologist, but how about, again, the worries about some of these volcanoes? Like when you think about, the volcano in, what's the name of it? In Yellowstone, right? What's the name of the volcano? There's a name for the volcano.
The caldera.
The caldera, right. Mm-hmm. How about the caldera where, it has erupted 3 times. I think one of them was 2.1 million years ago, 1.3 million years ago, and 640,000 years ago. And we're overdue for it to erupt again. And every time it erupts, some 80% of America gets destroyed every time it's erupted.
In these uncertain times, if there's anything we need people to believe the future looks bright. So if you've heard about me saying this mission to you, we're on a mission to get 1 million people to wear this gear. And this is what we're doing. If you buy one of these hats, there's a category of buying one hat, getting the second one free. If you haven't yet worn this gear publicly, go ahead and test it out. Buy some of the gear, wear it in public, and see how many people will stop by and say, you also watch Valuetainment? You also follow PBD Podcast? I do too. Place your order. Go to vtmerch.com, click on the link above or below, place your order, and represent the VT and the PBD Podcast gear.
So if you like this clip and you want to watch another one, click right here. And if you want to watch the entire podcast, click right here.